Hi, good morning, good afternoon, or good evening, depending on when you are listening or watching this video. Welcome to South Data Science Introduction, and I'll be explaining what data science is all about, and how data science work, and how you can break into data science or data analytics. Okay, so let's get started. So there has been several controversy regarding what is data science and what is data analytics. Okay, so a lot of people have been asking a lot of questions regarding what is data science, what is data analytics. Are they the same thing? Does a good job of a data science and a data analyst, are they the same thing? What are the requirements, and what tools, what language, and what things are required in order to break into this field? So these are questions that a lot of people ask. Okay, so I will be walking you through what data science is. So now, why data science? Now, data science it's a combination of mathematics, statistics, and computer science. Okay, just a branch of three of them combined together. So when we talk about data science, we talk about trying to acquire data, analyze the data, and visualize the data, and also do some further deployment of the data with a machine learning model or algorithm. Okay, so first of all, what a data analyst or the data scientists do is what's called data collection. Okay, now if you can see from here, we have, as you can see from here, we have data scientist. Okay, so data scientist does everything from collection, that's data collection, data cleaning, expository data analysis, model building, and model deployment. I'm going to explain each of them. Okay, so what I'm going to explain this first stage, which is data engineer. Now, data engineers are those who perform data collection and data cleaning. Now, looking at what are the methods of data collection and data cleaning. Okay, so in plain sense, data collection is more of acquiring data either from a database, or you carry out a survey form, a questionnaire where you share out and try to get people's response. Okay, that's if you are doing a project. But if you are doing, most times as a data scientist, you are being given the data to work on. Okay, so what you'll be doing majorly is cleaning or data manipulation. That, for example, you are given a data A and you are giving data B, and you have to manipulate the data in order for it to fit in what you want to visualize. Okay, so that's where we talk about data collection and data cleaning. Now, data cleaning has to do with removing missing values or unwanted things that can affect your visualization or your model. Okay, so for data engineers, what they do is they collect data and they clean the data. Okay, now what does a data analyst do? A data analyst, all they do is that they get the data from data engineers, right? Okay, they do cleaning and expository data analysis, also called ADA. Okay, so when you do cleaning, that is, you clean the data, you remove missing values. What I mean by missing values are empty space, unwanted field in a data set. Okay, now what I mean by data set is like a form of a spreadsheet, or data set comes in different formats, either CSV, SQL, or Excel, but most times a lot of people use Excel. Okay, so a data analyst, what they do is they collect the data from data engineers and they clean the data by removing missing values and any field that does not meet or that does not regard to the objective of their visualization. Okay, so a data analyst usually analyze data and visualize data. That's why we have clean and expository data analysis. Now, expository data analysis has to do with exploring each field of the data. So most times a data analyst explore each field of the data, trying to see, okay, for these data sets, we have about 2,000 rows on this data set. And we notice that like 55% of the data are missing. So how do we go about it? There are ways to deal with missing value. Okay. Later on, when we do pandas library in Python, we're going to see how to deal with missing values. Okay. So exponential data analysis, you are trying to visualize each column or each field of the data set to see how they relate, or you try to match a column to another and visualize it to see what's their relationship, how does it make sense. Okay, so let's say for example we have a payroll data set. Okay, a payroll data set comprising of the employee's name, employee number, employee phone number, employee spouse number, phone number. We have employee role, we have employee rank, we have employee salary, and we have employee allowance. Okay, so just imagine that kind of data set. Now, for this data set, you try to match, visualize the data set. Let's say, for example, we are trying to compare the employee, we are trying to compare, okay, which of these employee has the highest allowance and highest allowance. Okay, for example, now an highest paycheck. So how do we go about it? What we do is we visualize. Now, visualization we have different type of visualization. We have bar chart, pie chart, histogram, box, count, plots. There's a lot of plots in that Seaborn has given us, that Seaborn library has given us, which we'll be exploring later. Okay, but for now, we have cleaning and expository data analysis, which is what a data analyst do. So later on in the slide, we're going to be seeing the tools and the tools most data analysts use for their visualization. Now let's talk about model building and model deployment. Now, what the people responsible for this are the machine learning engineers. So a lot of people on LinkedIn or on various platforms would say, oh, I'm a machine engineer. So their task is all about model building and model deployment. Now, model building in the sense that after a data analyst has probably visualized the data, right? They have a sense of what the data set is all about. The next thing a machine learning engineer does is that he tries to see if there's a way they can do some they can have more insight about the data. For example, take a supermarket data set, okay, that has been in business since 2017 till date, and now they want to see, okay, what's after the COVID pandemic that happened? How can they what's the probability of, or what's the chance of making sales profits, big sales in 2022 and 2023, before the end of 2022 and 2023? How can they make a big sales? Okay, how can they make profits? So what a machine learning engineer does is he gets those data sets, right? He tries to see, okay, what column and what column can I use to make predictions, okay, in such a way that I'll be able to forecast within this specific period of time. And the board of directors or the management will be able to see, okay, this is where we need to put in more efforts. So what the essence of data visualization, the essence of data analysis, the essence of what a data scientist do is to present a kind of simplified form of the data set given in order for them to make complex or simple decisions. Okay, so in most cases, board of directors, they don't have time to sit down to look at what a data set is, what is the data set, what is their profit or this. That's why a data analyst or a data scientist is needed or is required for that kind of job. Okay, so now let's look at the last one, which is the data scientist. So a data scientist in all do all this, that is data collection, data cleaning, expository data analysis, model building, model deployment. So you can decide to specialize in any of these, but as a data scientist, which we are going to train you, you learn how to collect data, you learn how to clean data, you learn how to explore the data, you learn how to build one or two models, okay? So, but later, if you want to advance, you can decide to go into machine learning engineering, where you learn how to build model and also deploy model. Now, the model deployment is all about integrating a particular model you built into a web app or a mobile app or a website, either way. Okay, so what they do is, okay, let's say for example a diabetic prediction model. Okay, after developing after developing a model for diabetics prediction, you can integrate that model to a mobile app or to a web app, okay, in such a way that once someone inputs there are probably some fields like their weight, their blood level, their blood pressure, and other stuff, then they click on predict. You'll be able to tell them, oh, with based on all this stuff you filled in, you have like 20% or 90% chance of having diabetes or not. Okay, so that's just the end goal of what a data scientist do. Now let's move on. Now, what are the process of data science? Now, data science life cycle, as I've said earlier, data collection, data cleaning, expository data analysis, model building, and model development. So this is just the process. First of all, data is the key. You cannot be a data scientist without having a data. Okay, data is the key. So you have to collect the data, you have to clean the data, because a good visualization, a good model depend on a clean data, not this case. Because if you don't have a clean data, there's no way you'll be able to make good results. Okay, it's just like if a student don't read well for an exam, you'll not be able to have a good score. Okay, so if you don't have a clean data, you'll not be able to have a good or accurate prediction or accurate visualization. Okay, which can be misleading to the board of directors. Okay, so moving on. Now there's something called OSEMN, okay, which is still all the same thing, which is obtain data, scrub the data, explore data, model data, and interpret results. Now let me explain what obtain data means. Okay, obtain data is similar to data collection. Okay, and now data collection can either be, as I've said earlier, either be a survey. It could either be that you export from a database, or you are given a data set to work on. Okay, so when you obtain data, you need to scrub the data. Now, when I say scrub the data, it's the same thing as data cleaning. Okay, you clean the data, as well as you need to manipulate data. There are times where you are given like 4 data sets and you need to like join them together, like kind of adjust them together and combine everything together, remove some unwanted columns that does not meet the objective of what you want to visualize or analyze. Then you go to explore data. Now, after cleaning your data, you explore each field of the data. You try to understand, okay, let's say, for example, we have the age columns in the data set. You try to visualize it, probably with a pie chart or a bar chart, okay? And you see, okay, this is also employee. In this company, we have like from age 30 to 40 as the highest age in this company. So the board of directors will be able to say, oh, okay, so I think from the least people, let's say, for example, we have like 20, we have like 18 to like 25 as the least employee in the company. The board of directors will be able to say, okay, let's give these people kind of this social amount of bonus every month to add to their salary. Okay, so it's that's why it's there for us to explore the data and understand the data. Okay, so exploring the data, there's also something called the data dictionary. Okay, data dictionary is like a form of dictionary, just the way the word imply, or a form of like a database having the keyword of each column of the data set. Okay, let's say age, gender, phone number, employee ID, employee role, employee rank. So all those columns I just listed are the fields, okay, in the data set. So each of these fields can be explored. Okay, now let's talk about model data. Now, model data is still the same thing as data modeling. Okay, you use an algorithm. There are several algorithms. We have four. We have four classification of machine learning, which is the supervised, unsupervised, semi-supervised, and reinforcement learning. Okay, we're going to look at this later on when we dive into machine learning. Okay, now interpreting the results has to do with presenting the results to your board of directors or your management or the management. Okay, in sense that once you have like a PowerPoint slide, okay, which or an interactive dashboard. Okay, a lot of board of management and board of directors will love to see a beautiful interactive dashboard where they could interact with, because once they click on something, you should be able to reflect that, okay, in so and so days, in so and so month, there has been an increase or a decrease in our sales or in our transaction. This place and this place is where is needed for us to put in more effort to add in more effort and grow our business. Okay, so that's that for the Omen. Okay, so now let's look at the data science landscape. Now, data science, as I've said earlier, is a branch of mathematics, statistics, and programming, and and computer science. So the programming, the software engineering, the machine learning, the programming are the part of data science. Now, if you look at this place, we have programming. Okay, so programming, a lot of people use Python, R, okay, and Adobe. Adobe is an advanced for big data. Okay, Spark also for big data. But a lot of people use Python and R. Okay, I'm going to send us an article. I will attach it to the link below, where you will see why are these languages used, because a lot of people use R and Python for data analysis, for data science, sorry, because they feel it's easier and it has a lot of features that makes life easier. Now, mathematics, okay, it's required for you if you're diving into data science for real. You have to have a knowledge of discrete mathematics, linear algebra, probability, calculus. And for data visualization, okay, we have comparison, relationship, distribution, composition. Now, expository data analysis over here also. Now, before I move to soft skill, let me talk about data processing. For data processing, we talked about obtaining data, handling missing data, data cleaning, feature engineering, and feature selection. So these feature engineering and feature selection are under machine learning, okay, where you handle, where you have to select where you have to select the kind of model or algorithm you want to use. Okay, now the feature selections are like kind of column you want to use for your analysis. Okay, if you want to analyze like 2 or 3 columns or in a data set. Okay, now let's look at the software engineering. The software engineering has model deployment, where I told us about integrating a model to a mobile app or a web app or to a website. Now we have tidy code, that's neat code, parallel computing, optimized code, software development best practice, data structure, and web development. So it's also good to have an idea of web development, because like just know how to set up a website, okay? Because most times integrating a model, if you are going into data science for real, integrating a model into a web app requires you to learn some frameworks. Okay, for example, I use Django or Flask for my integration from model to my web application. Okay, now let's look at statistics. For statistics, we have differential statistics, we have hypothesis testing, we have experimental design, we have descriptive statistics. So all this stuff comes in handy when you dive in to data science in full time. Now we have advanced neural network. Okay, the neural network is another section of machine learning. Okay, but it's kind of advanced. Okay, but let's look at machine learning. Machine learning has the supervised, the unsupervised. We have the clustering, that's for the unsupervised. Then we have k-means and principal component analysis. So all these are so you could look into for neural network. We have deep learning. Deep learning has CNN and GEN and back propaganda. So all propagation, sorry. So all these are advanced learning. So like random forest, XG booster, decision tree are under trees, which are advanced, which are the models used for in machine learning. These are models used in machine learning. Like K means are models used in machine learning. Now let's talk about the soft skills. Now for soft skills, these are very, very important. They come in handy as data scientist or a data analyst in presentation. Okay, for example, you don't know how to do storytelling, you don't know how to create a PowerPoint slide, you don't know how to do some write-up, then it's going to be difficult for you. So it's advisable to learn some soft skills such as storytelling, presentation, creativity. It's also good to be creative. In that is creating something like, for example, if you are designing a dashboard, okay, it's very good for you to be creative. Either you are using Excel for dashboard or you are using Power BI or using Tableau. It's very good for you to be very creative. Now we have critical thinking. Okay, critical thinking is very important. You may be dealing with financial data sets. You need to be very you need a very critical thinking in that aspect. Then you need communication. Okay, communication comes in handy when you are giving your slide presentation. Then domain knowledge, okay, you have to have knowledge about that particular field. Okay, a lot of times, most data scientists are giving data sets regarding finance, some health sector, some agriculture sector, some tech sector. So as a data scientist, it's required for you to have a knowledge about the domain, that is that aspect, that sector. Okay. Okay. For example, working on a data set for health sector, and you're not you're not an health person. I mean, you're not into the health sector. It's advisable for you to learn, and that is do some read ups. Okay. The internet, I mean, the Google is our friend. So having access to internet, do a lot of read ups on what are these columns. That's why we have data dictionary. Okay, it's good to have a data dictionary for a data set where you try to understand the meaning of each column, what each column means, and what they're talking about. Now let's look at problem solving. Problem solving, you need to have that soft skill also. Now curiosity also. Curiosity is very, very important because you need to, for you to go far, you need to be curious. Okay, how can I make sense with this data? What can I make, what sense can I make out of this data set? Okay, now you need to learn writing. It's also good to learn writing. Having a blog is also important. Then lifetime learning is very important. You could have a lifetime you should have a lifetime learning at the back of your mind. So if you are if you are pursuing cyber data science as a full time individual. Okay, now let's look at the tools used in data science. Now we have Python. Okay, now most data scientists, most data analysts use. Okay, now let's talk about data science. A data scientist usually use everything here. Okay, they use Python, Tableau, Excel, SQL, R, SAS, SES, SPSS, Matplotlib, and Stata. Now, but a lot of data scientists use Python, Tableau, Excel, R, SPSM, SQL, and SPSS. A lot of them, but a lot of people are familiar with R and Python. R and Python are programming language. Okay, Tableau and Excel. There's no Power BI here. Okay, this Power BI owned by Microsoft. Okay, so a lot of people use this software for their day-to-day activity as data scientists or data analysts. Okay, but for any individual trying to break into data science, I would recommend learning Python, Tableau, Excel, SQL. Okay, it's very important. If you are someone going into research work, I recommend learning SPSS, Stata, and SCS. For math lab also, I think it's also good, recommended also. Okay, so now career in data science. How do I start a career in data science? Now, how do you launch your career in data science? Okay, so the first or the zero step I would advise is figure out what you need to learn to get into the labor market. Okay, for example, if you are not in Nigeria or you are in Nigeria or you are in other part of the country, it's good for you to figure out what the labor market is. Okay, what is the labor market? What's the competitive labor market on data science? Okay, you could do some research. follow a lot of people on LinkedIn and see what a lot of people are doing in data science space. Then you try to figure out, okay, I think, okay, what is the data science booming in that place? Permit me to use the word booming. Okay, now the first step, the second one, or the step one, is get comfortable with R or Python. They are because they are most common languages used. Then step two, learn data analysis. Okay, learn data analysis, that is, learn how to analyze data using most to learn how to manipulate it and learn how to visualize data. So visualization comes in with pandas. That's where we use pandas in Python. Then learn machine learning with scientific learn. Scientific learn, that's SCIKIT learn. It's also called scientific learn. So that's the library in machine learning, that like the family library. They call it family library because it houses most machine learning models. Then understand machine learning in depth, more in depth. You need to understand what machine learning is all about. Then keep on learning and practicing. Okay, one day you're going to get it full time. Now, application of data science. So data science can be applied in different sectors. We have the applied public affairs, computer science, international economic relation, cybersecurity, business analytics, finance, environmental science, biotechnology, microeconomics. So these are like the areas you can apply. Then, okay, for me, I'm a lover of cybersecurity. I love this aspect. So for me, I could say, okay, network security and computer network and security is a very malware detection. It's a very good aspect of applying machine learning. So okay, secure software development also. So these are the various fields you could take your time to look at. What aspect can you apply your data science to? Like for finance, like fintech companies, they actually need data scientists or data analysts, both actually, to do some risk management, fraud detection, and manage customer data and try to see how they can get to advance their digital marketing, scale up their digital marketing. Okay, then let's look at this video. So this video, I'll drop the link. The different roles that exist. I'll drop the link for us. The reason why I added this video is because I find it very interesting. The guy actually literally analyzed what data science is all about. So I'm going to drop it in later for us. Now let's look at data analytics. Now a data analyst, okay? Don't get it confused. We have data analytics. A data analyst, someone who is into data analytics, is called a data analyst. So data analysis, that's analyzing data, can refer to a variety of specific procedure and methods. Okay. However, we mean that data analysis involves goals, relationships, decision making, and ideas in addition to working with actual data itself. Okay. So in simple format, simply put, that data analysis includes ways of working with data, that is information, to support the work goal and plan of your program or agency. Okay, so in summary, data analysis involves working with data. You know, data is raw. You're having a data set. If I have a data set and I just give it to my boss, it's just going to be like, okay, what is this all about? Can you get me some visualization to make my life easier? So that will literally be his response. So that's why we said data, working with data to support the work, the goal, and plan of the program or the agency. Okay. Now we present a data analysis process that includes the following key components. Now for data analysis, we talked about data analysis has some key stuff. That is, you should have a purpose for you to analyze the data. If I am to analyze the data, okay, I should have the reason, like the purpose. Okay, if I'm trying to get, I'm trying to get my boss to be able to make decision with this data set. I'm trying to make sure that whatever I'm going to analyze or visualize should meet the objective. That is the aim and objective of whatever the tasks have been assigned to. Okay, now the second point is the questions. Now, my data or my analysis or whatever I've done should be able to answer a lot of questions that my board of directors are unable to, or they are finding difficult to answer. For example, you work in a fintech company as data analyst or a junior data analyst, and you notice that the customers comes in, they opt into the platform, and before the end of the quarter of the year, a lot of people withdraw their money from the platform, and it's reduced the profits made in the company. So these are like the questions. You identify the problem in the company and you try to see how to tackle those problems. So that's where questions comes. Okay, so what's the issue with these customers? So you try to analyze, okay, how many customers are leaving the platform? What are the reasons? Okay, so then we have data collection. So it's from those questions you have to collect your data and analyze the data. That's data analysis procedure and method, then interpretation and identification of findings, then writing, reporting, and dissemination. Okay, so when you write, when you are done, you do some write-up explaining your work, then you do some reporting and do some dissemination and evaluation. You evaluate, oh, was I able to meet the objective? Was I able to answer the question? Then we have several tools for data collection, mostly survey or questionnaire. We have the type form, we have Kobo Toolbox, and we have Google Forms. So a lot of people are familiar with Google Forms, and a lot of people are familiar. I don't think a lot of people are familiar with Kobo Toolbox. But Kobo Toolbox is a very powerful software. It also has its own features where it allows you to analyze your data, allows you to visualize the data. Like once people fill in the form, right, you'll be able to see a chart, okay, in it. Even Google Form 2 has it also. Okay. Then we have what information can help us answer our questions. So data collection is a process in and of itself. In addition to being a part of large whole, data comes in many different types. Okay, so see the discussion below. Okay, so we're going to have a discussion below now, and can be collected from a variety of sources. So a lot of data are from observation. Okay, you could literally be observing an experiment and just jot them down, write a report. But don't forget, data analysis work on medium data sets, large or medium data sets. You don't work with any data, you don't analyze or visualize on a small scale data set. You can, but it might not really make sense, okay, per se. Okay, but when you have a medium data set or a large data set, you could be able to visualize. Then we have questionnaire. So a lot of people get questions from get questions or get a data set from questionnaires. Some get data sets from interviews, okay, to see people's performance. Then documents, okay, a lot of people get data sets from documents, some from tests, and some other means of getting information. Now let's start the discussion. Now, data collection limitation. Too little data to answer the question. That's what I'm just trying to say. That if you have little data, it will not be able to answer most of your questions. Okay, so it's required to have a medium or a large scale data set. Okay, more data than is necessary to answer the question. So if you have big data, okay, then you might not be using data sets, and you might not be using some traditional tools. Okay, we have traditional tools and we have advanced tools for data, for big data management. Okay, but more data than necessary. Let's say, for example, we want to know the age range in a company, and a lot of people in the questionnaire survey are putting 100, 120 as their age. Okay, so that's an unnecessary data. That's an outlier. That's something that is not needed. So it's not needed. So that's more of like an unnecessary data to answer the question. Okay, then data that is not relevant to answering the question. So a lot of people, when you send out a survey for them to fill, and a lot of people just end up filling things that are unnecessary, so you have to remove them. So now let's talk about data format. We have CSV. CSV stands for comma separated value, where you see your data separated by comma. Okay, we have SQL. SQL is structured query language. From database, we have different type of database. Okay, either traditional or non-traditional database, but we have database. Okay, then we have XLSX. Okay, so this is more like from an extension called Excel. Then we have the HTML. A lot of people extract data sets from a website. Okay, so we are going to look at each of these formats when we are looking at pandas. Okay, when we get to Python, we look at pandas. Okay, now in order to successfully manage data collection process, programs need a plan that addresses the following. What type of data are most appropriate to answer the question? So these are things you need to give your answers to. What type of data are most appropriate to answer the questions? Okay, how much data are necessary? Okay, who will do the collection? Okay, so we know that data engineers are those that do the collection. So if you go on Indeed, there are a lot of Indeed or LinkedIn, there are a lot of job offer for data engineers. Here, companies say, I'm looking for data engineers to do data collection for them, and in return, they give them little cash. Now, when and where would the data be collected? It's very important. And how would the data be compiled and data stored? Okay, a lot of people, they do paper-based survey. Okay, and a lot of people, they don't know how to present questions when they do survey. Okay, let's say we are looking at HIV in Nigeria, for example, or in a particular state, and they end up doing a survey. Okay, now there are guidelines, there are rules, there are principles to designing the question. Okay, a lot of people don't know how to design questions for users because too much questions or lengthy questions can make a user or someone who wants to fill your form uninterested in filling it. So there are principles. So now how are data compiled? Data can be either database or can be either electronic or paper based. But most it's advisable to use the electronic, because even if you use the paper based, you still have to like compute it into the system for you to be able to analyze. So the computer base is best and suitable. Now let's look at this chart. This is just an Excel dashboard. Excel is a very powerful tool also for visualization. With Excel, you can create amazing visualization. Okay, very interactive. Okay, this is for an Amazon Studio database for their movie. Okay, so this is the distribution by. So these are questions we are trying to answer. Like for example, over here we are saying top countries by production. The top country with movies color production. Okay, so you could see the legend also. Legend are here, and you could see top 5 profitable movies. Okay, with their names and the money and the rest. So Excel is also a powerful tool. Let's look at this is also Excel. So these are called slicers in Excel. Okay, you could do more read up on Excel for visualization. You could visualize with Excel. Okay, and we have Tableau. So Tableau is a software. You can either pick from Tableau or Power BI. But for me, I went for Tableau because I found it very interesting and interactive and good. So Tableau is a very good software, but it has a premium version, the enterprise and the rest. But this is Tableau public. Okay. Then we have so this was an analysis done during COVID-19. Sorry, the picture is not that sharp. Okay. So this like a visualization of it. Okay, same thing. So in summary, right? In summary, this is what data analysis is all about, and these are the tools mostly used. Okay, I don't think they include Power BI here in this image, but it's also called Power BI. So you could check Power BI. A lot of people use Power BI for their visualization. So you could visualize with Power BI, Excel, Tableau. Okay, these are like major softwares a lot of people use. Okay, for SPSS, Minutes Tab, these are softwares also, but a lot of people use them for research purpose. Okay, so you could do some read ups here. You could click on this link to do some read up. I'm going to put in the link below. You could do some read ups on this slide. Okay, so that's the end. Thanks for coming, and hope you learned one or two things from it. Kindly like, share, and subscribe. Thank you.